Hello. So in this video, I will try to Dockerize the application that we've been building so far, and try to deploy it, try to run at least two containers, one a master and a slave, and making the slave connect with the master container and seeing the commands trickle down from the master to the slave node. And I'll write a simple PowerShell script to send commands to the master node so that we can see in real time my slave container being updated, the command trickling down to the slave and it updating its own state. So let's just start with creating a Docker file. I need to rename it. Rename Docker file, and I need to bring it out. Yeah. So in my Docker file, I need to first add a base image, and it's going to be this base image, and I'll call this stage as build. I'll set the working directory to be /app, and inside this I'll run the following command to add Maven in this base image, because this base image does not have Maven, and so we need to add it manually, which this command will do for me. Now I need to copy the pom.xml file to the working directory that we've set before, /app in line number 2, and then I can copy the source folder. Copy src to src, and we'll copy src to src, and now we just need to run the maven package command, and you already have that in your repo if you've been following my content, and if you have created a repo from CodeCrafters, you will have this command in your program.sh. This is essentially the script that CodeCrafters run to test your application. This command packages your application and this command runs your application. So we're going to do the same thing in the Docker file. We just need to run the package command, which will look something like this, and after that we just need to create another stage. So this stage right here is the build stage. Now we'll have the stage that will be actually running, you can call it the prod stage or anything. It's the final stage. It's a multi-stage Docker file, so that the end image is small in size. That's essentially the purpose of multi-stage Docker files. And let's just add another stage. So this base image is lighter than this base image. That's essentially the point of having multi-stages. We don't need the development kit to run the application, and so when we add this stage, the final container will be running on this base image, and that will be a lightweight image. So that's the benefit of it. Work that is /app, and now I just need to see when we run this package command, it will have generated a jar file for me, which we can even see in this. Maybe I do not have it. Okay, so I do not have it in my target folder right now. So this will generate a jar for me, a jar file which we can run, and you can see them running the jar file. See CodeCrafters running the jar file in the shell script as well. And I need to do the same thing I need to first copy it from the build stage into the final stage. So that can be done with this simple copy command. So what this command is doing is it's copying from the build stage the jar will be generated in this folder into the working directory of this final stage, which is set to be /app. So now this /app will only have the jar file. It will not have my code, only the jar. Okay, and the jar file is being generated in this temp folder because that's where CodeCrafters is generating our temp file. I simply just copied these commands into the Docker file, that's it. And after this we can set the entry point to be you see this exec command, this is essentially the entry point of the application. So I just need to set the entry point to be java-jar and the jar that we copied from the build stage to this stage. All right. So with this, we should be able to build our application at least. Before I build the application, let me add some log statements to my code so that you'll be able to see when my master is trying to communicate with the slave and when the slave is receiving communication from the master. So what we'll do is we'll go to the master TCP server and handle client, handle command. So right here I have right here. So this propagate command this function is what sends down commands to the slaves, right? So right here I'll add a sout so that we can see it in the Docker container logs. I'll add a sout to and I'll print the command that we are sending as well. So we can send the command sout the command resp string, and this is the command. And we can even, I think we can even sout the configuration of the slave that we're sending it down to, so, right? So slave dot connection, this is the socket connection, and I can print its ID. I can also print, let's see, what all do I have in my connection. My connection is a client. My client has an ID and it has a socket, right? So I can print its IP address. I just need to get it out from the socket. So what I'll do is dot socket dot get inet address. So that should print the IP address, I suppose. I think so. What does this method do? Returns the address to which the socket is connected. If the socket was connected prior to being closed, then this method will continue to return the connected address after the socket is closed, the remote IP address to which the socket is connected. So it returns inet address, but do I need to convert it to string? Inet address, does it have, let's see. This returns an object of inet address, so that will not work. I need to write the host address. I need the host address. And does it have the port as well? Get address, host name. I think host address should suffice. Does it have the what does it return? Get host address. So it returns host name dot toString. So can we do toString instead? So I don't think we need this. Let's just see. We'll create another image if required. Or let's just Google. I'll do AI instead of Google. The IP address and port number of socket instance in Java. Am I out of free credits? Is that the issue? No, it's working fine. So get inet address, get port. So it returns the get inet address. I can do get inet address, and then I can do get port and get local address on the socket. Okay, so what I'll do is instead of inet address, I can do get port, get inet address, remote, and socket.get port. Okay, so I can just do get port. Okay, so that will give me the port but I also need the IP address, and IP address is in socket.get local address. And no, I don't need the local, I need remote address.get host address. So this, and instead of socket I have client.connection.socket, slave.connection.socket, slave.connection.socket .get inet address, that's the remote address, and then IP address is this. So I can sort it right here, and then I can append the port number like so. So that will print the slave IP address and port number to which the master is sending down the command to. So now let's get to the slave TCP server, and I'll print anytime a command is received from a master. So, oh, and see, I added this here, but my slave may have slave of its own. So we have this propagate method right here as well. So I can print it here as well. And when my slave, where does my slave receive a command from the master? It receives the command right here. So where am I processing the command? Okay, master REPL option. Where am I handling the command? Where am I handling the command? Oh my god, I forgot already. Handle commands from master right here. So right here I can print if I received any command from master node. You can add loggers if you want. And right here I can for string C in command, I'll print C plus space, and that should print the command received from the master. Alright, now I'm good to build the application. I can do a Docker build. So let's get into WSL and let's start Docker Desktop. Okay, let me delete the older containers and images that I created before starting the recording. Delete, and images, delete. Alright, now as you can see, my local Docker setup is completely empty, completely bare bones, and I can do an ls and check if I have the Docker file here. I do. I can do a Docker build -t my Redis on dot, and I'll add all these commands that I'm writing in the readme of this application, so you can get the commands from there. Should take a second. So it built successfully. I can do docker image ls. Docker image ls. I have an image. All right, now I can create containers from it. So yeah, instead of creating the containers here, what I'll do is, okay, so let's get into WSL. So these logs you see are from before when I was preparing for this video basically. So now my terminals are absolutely empty, and now I can run the master node. So the terminal on the left will have the master node, and the terminal on the right will have the slave node. And let's see how we need to run the Docker images to see the communication between the two. So Docker run -p, and I'll run it on 6379, and the image is my Redis. So another thing you need to think about is what IP address the slave node needs to use to communicate with the master. Because uh, when I run this container, localhost will not point to the localhost of my Windows host. It will point to the localhost of the OS inside the container. All right. And that's not what we want. I want to use the IP address of my Windows host machine when communicating with the master. So when I run this command, it starts the master node. Okay. And the IP address that we need to use to communicate with this can be fetched using this command. And you can see and you can check this command in the readme of this project. You can see it right here and type it out if you like, or if you're lazy, get it from the readme. And this is the IP address. This is the IP address that my slave node needs to use to communicate with the master node. Now, am I doxing myself? I don't know. I'm not that into network and security. I may be doxing myself, but who cares? Docker run -p. I'll run the slave node on port 6480. Alright, my Redis. And now my Redis, when we run a slave node, it expects some parameters. And we can see that in the main.java class. To make a node run as a slave, it needs a replica of flag when running. And with Docker, we can pass parameters to the entry point command by simply typing them out in front of it. So as I said, I'm going to run the slave node on port 6480. And it's going to be a replica of the IP address that we got right here, and the port 6379. Oh crap. 6379. So the master was on port 6379. My slave is going to be on port 6480, and it's going to communicate with this IP address, assuming this is the master node's address. And when I do this, now my slave should be communicating with the master. It should be sending out a handshake basically. And now what we can do is we can send ping commands to check whether my instances are working or not. So what I've done is I've written a small PowerShell script to do that. We'll use ISE to do that. ISE is just a editor for PowerShell scripts, and let's just look at the script at once. So let me go through it. So what this command does is it connects via socket on the localhost on this port, and then we get the input output stream in this object, in this variable, and I get a writer object. This is basically to which I'm going to write the commands, and this is the reader. Will read from the input stream, and these are the commands that I'm going to send down to the master or the slave node. So what I can do is, let's just try to ping both the slave and the master. So my master is running on port 6379. So what we can do is I can select it all and run it. So I received a pong back from my master. What I can do is I can change the port number, and this will connect now to the slave. So both the containers are working, I suppose. And let me just save it to, I'll call it ping.ps1. ps1 is the extension of a PowerShell script. So it's in CodeCrafter Redis Java, yeah. So it's saved. Now I can send down set commands to the master node. This is the set command, and the port for the master is 6379. So instead of closing the connection, I'll select these lines, these 13 lines, and then run that. So as you can see, a client was connected to it on this port. This client is this, and my master received a set foo bar command, and the ID for this is 1. All right. I might have goofed up a bit. Oh, sorry. Hahaha. This is it is sending down a command to slave, and the command is this, and this is the ID of the slave, and the slave is communicating with it on this IP address on this port. And if you see right here, my slave received a command from the master. Let's go. So now if I try to get foo like so, I should receive bar from the master. This is the port of the master. So the server responded with a $3. What is this $3? Actually, this PowerShell script is reading one line only. You can do this in a loop. I didn't want to write the loop. I actually don't know how to write a loop in PowerShell. And I took the lazy way out. And what I'm going to do is run this command again. And that will show you bar. Okay. And now instead, I can now close this connection. We should close this connection like so. And now instead of communicating with the master, we can communicate with the slave and check whether the state has updated for the slave or not. What I'll do is I'll select all of this and send a command down to, before that, let me do this and send a command down to the slave. And my slave responded back with a $3, as did my master. And now I can read one more line, and you see bar. So the state of the slave node has also updated. What happened under the hood? My master node, which is this container, my Redis container, it sent down a command to the slave. The slave received this command, it processed it and updated its own state. So all that replication you can see now in action, and maybe we can even see logs on Docker desktop. See, let's check log explorer. Do I have anything here? Yeah, I do. It's just the things that I outputted to the output stream with the sout. So you can add your own logs everywhere and see them here. It's just an extension. You can manage these extensions with the right here. It's the log explorer extension. You can see the logs of containers right here. I think it's pretty useful. Anyways, so now I have two containers. I have a Docker image and I have two containers running. One is a master, one is a slave. I can spin up many more slaves and all of them will communicate with the master. In fact, no, it won't work. We don't have RDB. Yeah. So instead of one slave, I could have spun up 60 slaves, and all of them will be communicating with the master, and the state of all those Redis slave containers will be updated. What that achieves for us is, if this IP address is available on the internet, and this container, the master container, is deployed on the internet, so the slave node can communicate with the master across the globe. So what we can do is deploy these slave nodes in a distributed fashion. One of my container can be in India, one can be in USA, one can be in China, and so on, and I'll have accomplished a distributed Redis cache network. So what we'll do in the next video is achieve this deployment on Kubernetes. That's what I hope to do. I'll deploy these containers on Kubernetes using Helm and then maybe Argo CD. So stick around for that. That's it for this video, and see you in the next one.